limits. This session explores how Agentic AI can transform data pipelines from reactive systems into self-healing autonomous platforms. We'll look at how AI, data ops, and observability come together to reduce manual effort and improve reliability. Our next speaker brings over 14 years of experience building enterprise-scale data platforms across AWS, Snowflake, streaming, and lakehouse architectures. Currently, a senior solutions architect at IBS Software and previously a senior associate at Cognizant, he now focuses on AI-driven data reliability. Please join me in welcoming Mr. Sreejith Surendran to the stage.
Hi all, good afternoon. Okay. Hope you all had a great learnings today. Okay. So my session is on moving from reactive to autonomous. So we all have working on the data engineering side. We have a lot of data pipelines to manage with. So this session is to reimagining data pipelines with the Agentic AI. Okay. So let's first start with the evolution of the data pipeline architecture, right? So when you move back maybe like 2 or 3 decades back, we were all into the manual era where we were having a lot of scripts, cron jobs, human intervention is required whenever we want to make any kind of a changes, right? Okay, and after that when 2000 we advanced a little bit, so we had orchestrated pipelines, we were having workflow engines, Informatica related talent, ETL related tools came up where we can do a lot of scheduled automations. Now we are into a reactive era where we get the messages or it's kind of an event-driven processing. We will get the messages. We have a lot of rule-based processing, right? Is that enough? Okay. Don't you have any kind of a pain in your reactive data pipelines? Can you name any pains which you are having in your current data pipelines? Okay, yeah. So it's very difficult to wake up at 3 a.m. and then probably addressing the query or like fixing it, right? You have to go through the lot of logs and then fixing it, right? So it's a painful task, okay? So what's next, or like how we can reduce some of this pain points, right? So we are moving into an era called autonomous data pipelines, where with the help of AI and agentic capabilities, we can automate a lot of manual activities which is involved in the current data pipeline architecture. So that can be done with autonomous self data pipelines or the self-healing data pipelines, okay. Moving on, I think these are the kind of pain points which we usually saw in the data engineering world. So when we have those data pipelines, right? So we have to manage these data pipelines as well. So there are a lot of manual monitoring activities which a team will put into this activity to ensure that our data pipelines are working in a seamless fashion. So we spend almost like 40 to 50% of our time in monitoring these dashboards, responding to alert and investigating failures and all. So this is too much, right? So you are spending almost 50% of your time for doing this kind of a small, low intelligence level activity. Okay. Similarly, if you look at when you get a production incident, if it is a P1 or P2, there are similar SLAs are associated with it, and maybe like the time to resolution will typically spans around 2 to 4 hours just to resolve those kind of incidents. So there is a delayed incident response in whatever cases we are working on it. Okay, this always leads to maybe like a customer satisfaction issues. It can materialize some of the business impact. So you may be having a dashboard which is not running and some of the analytics reports are not able to catch up. So there are always delays with instant response, and it can lead to your business problems also. And if you look at all of your traditional data pipelines, right, so you will be having a lot of rule has been written. So if there is a kind of a, let's say, amount calculation, there is a ticket amount calculation. So we are having a rigid rule which has been set up. So it may be a combination of certain attributes which you may need to sum it up, or sometimes it will be in some other format. You have to put a lot of rules you have to ingest into your system to make it like to make it work, right? And then the scaling bottlenecks. So you don't know when your pipeline need, what is the optimal resources you need for your pipeline. So sometimes you may under provision it, sometimes you may over provision it. So this has been a problem. Okay. Okay. So when it comes to the autonomous systems, what we are thriving is like an autonomous data pipeline system will leverage AI agents, and that can perceive their environment, and then it can make intelligent decisions and take corrective actions without any kind of a human intervention. That's what we are planning to do. This is more of a goal-based approach where you say you are having a data pipeline. The goal is to ensure all of your data pipelines needs to be up and running all the time based on the schedule or whatever the time it needs to be available, and maybe like for different business purposes. Okay. And what are the key capabilities an autonomous system needs to have? Okay, it needs to have the self-diagnosis. It should be able to automatically identify the root causes of the failures, and it should be able to adapt to the new learnings also. So you are having different performance parameters. It keeps on changing due to maybe like new volume is coming up. There are new uptick of the volume. Based on that, you have to adapt it, right? So there is an adaptive learning you need to inbuilt into your system, and then you have to take predictive actions, not reactive, based on the data and how it is changing. Based on that, you have to predict the data, and then based on that, it has to take actions to avoid future issues. Okay, and you have to optimize it for the dynamic for ideal performance state. So you have to have a dynamic optimization, which is a key component of your autonomous pipelines. Okay, and then this decision should be contextual also. So whenever you are taking, you have to understand what is the business environment, how this particular change will affect the businesses and all. Based on the business understanding, you have to make contextual decisions too. Moving on. Okay, how AWS Agentic AI is going to help us resolve these problems, or like how we can create an autonomous data pipelines using the AWS Agentic AI. Okay. So there are three of these components are kind of a key aspects to make this autonomous data pipelines to make this work. Okay, one is the foundation models. You all know foundation models is nothing but it act like the brain of this process, and autonomous agents, they are kind of a workers, right? So they do execute the task. Okay. Now the third thing which comes into picture is orchestration agents. So when in data pipelines, you are having a lot of tasks to do. So you may be waiting for a file. Once you get the file, you have to do a lot of cleaning activity on top of that file, and sometimes you perform certain transformations on top of that, and then you push to analytics workflow for probably you create your own fact and dimension tables and all, right? So there are a lot of activities. So you need to have a coordinated multiple agents needs to be available, which needs to coordinate these actions. So we have something called orchestration framework. So we have famous LangChain and maybe like AWS's own strands and all, which will help us to do this kind of orchestration of multiple agents, which will help us to achieve the business goal which we are targeting for. Okay. Any questions? If you have any questions, please raise your hands. Now, when it comes to in the previous slide, we talked about the key components which is needed to implement the Agentic AI in the data pipelines. Now, when it comes to the next set of these are all the tools which will enable you to achieve that that functionality, right? Okay. So one is the Bedrock Agent Core. So throughout the day, we are hearing about the Bedrock Agent Core. This is something which provides the foundational runtime environment, memory management, all those stuff which makes the agents live and running. Okay. Now comes the key part. So multi-agent collaboration. So when we talk about the data pipelines, so you have to interact. You need multiple AI agents which needs to be interact together to get the desired output, right? How we are going to achieve this? So multi-agent collaboration will help you to achieve that. Okay. So briefly touch base more on the multi-agent collaboration. So this is something the native the orchestration framework which AWS provides. So you can do it through other ways also. So you can have a kind of a when it comes to probably the data pipelines, right? You can have a kind of a supervisor agents which can coordinate agents and delegate tasks to multiple other agents. So you can have a diagnostic agents which will do analyze the memory anomalies in the data and then perform the root causes and all. And once it did the diagnostic part, I think there is a remediation agent which can execute the fixes and the recovery actions as too. So and then there should be a monitoring agent which should always monitor the resources across the entire ecosystem or the entire agent ecosystem, and it will help you to make whenever there are changes or whenever there are system health related issues has been noticed. Okay. Okay. When it comes to the Bedrock Agent Core, I think this is something which we talked about or like which we heard throughout the day. So it is having the features as like it provides the runtime capabilities, gateway, observability, memory, and the identity and the agent core. These are all there. Okay. Moving on, I think this is again related to the Bedrock, so I'll skip this slide. And okay. So AWS Lambda plays a key role in building any kind of a autonomous data pipeline system. So what we need to do is like we know AWS Lambda is kind of based on the event trigger it can act upon, and it can perform in this way, like you can use Lambda for the event detection, and there are AI analysis and the intelligent action and the learning loop. Okay, so Lambda functions can subscribe to event bridge probably S3 events, DynamoDB streams to capture the pipeline activities in real time. And the AI analysis, it can invoke the Bedrock models to analyze the event context, assess severity, and determine the appropriate response actions. Okay, and then it can again do the intelligent action with the help of step functions, or it can do by its own, and it can retry the failed job, scale resources, route data to alternate paths, and or escalate to human engineers as needed. Okay. And the last one is the learning loop. It can store outcomes in DynamoDB for continuous learning, improving future decision making easily. Okay. So, to make the AWS Agentic AI or to make the autonomous data pipelines, this Lambda plays a key role to it act as the kind of a hands-off or your AI agents. It can involve whenever the AI agents are needed. Okay. Moving on, I think this is about the SageMaker, I guess. So. I think using SageMaker, you can do the data collection. With the help of that, we can do the model training and real-time inference and the model monitoring you can do. I'll skip and go to the Glue. Okay, so when it comes to the AWS Glue, I think it has the intelligent data cataloging feature, smart ETL operations, adaptive schema, evolutions and all. This will help you to implement the AI-related features into your pipeline automatically. Moving on, I think this is the part which I am more keenly into it. So you have a ETL pipeline, right? So how it will be? So you will be having a data ingestion layer where you receive the data, you do some kind of a data transformation activity, and then you will load it to your maybe like the fact and dimension table, right? So this is the traditional ETL models we all say. Okay. Now there is another paradigm which has been very prominent nowadays is ELT. So you extract the data from multiple sources, you load it, and then probably transform it. So the transformation responsibility will goes away from maybe like from the platform team to the corresponding reporting teams for the BA folks and all. Okay, so we get the file. So we have to do some kind of a processing, and then we have to prepare maybe like the fact and dimension tables, right? So that's how it needs to do. So let's put this in how we can make an AI-driven automated pipeline can work in the case of an ETL or ELT file load activity, right? So you got a data ingestion layer. Okay, so you get the data. So as soon as you get the data, you will be having some notification somewhere, right? So you will be having S3 events will trigger Lambda functions that say, hey, you got the right data. So that will invoke Bedrock agents to validate the incoming data quality and then schema complaints. So you can validate what are the data you received. So are the mandatory attributes has been received or not. So whether it is aligned to the schema. So you might have predefined the schema. So you are not expecting you might be expecting a number value in the ticket number or probably in an amount column, right? So you can validate all those things. Okay. So now you have to do this processing, right? So there is a processing layer which will be the next to this. So what it will do is like it will execute the ETL with the AI powered transformations. So you can use the SageMaker endpoints to continuously monitor the metrics for any kind of a data anomalies. Okay. Now there is an intelligence layer. Okay, so we got the data, we did the processing part, right? So there is an intelligence layer too. Okay, so what if there are some issues with respect to the data you received? So in the CloudWatch errors logs, you are seeing some errors or some kind of an unknown kind of a data anomalies, right? So how do you do that? So you have an intelligence layer built into it. So it will be having the Bedrock agencies which will be analyzing the CloudWatch logs and metrics, and it can make decisions about scaling activities. Let's say your job failed and maybe like it was due to some kind of an infrastructure issue. So you can try rerunning your EMR cluster and so on, right? So you can apply a retry strategy, and then probably if there are any kind of a error handling which you can do, if you built that into the solutions, then that will all goes to the intelligence layer. Okay. Now you analyze the data, you found that there are certain activities which needs to be taken, and where you will do it. So that's the place the action layer will comes into picture. Okay. So with the help of AWS step functions, you can orchestrate multi-step remediation workflows. Okay. Let's say you may need to update certain databases, certain tables in the database, and after that you may need to rerun the job, right? So there are two actions involved. So one, you need to update the table, and now you need to rerun the jobs, right? So those kind of a multi-step remediation activities can be a part of your action layer, which will be which can be triggered with the help of a step function, or you can do with the glue jobs as well. Okay. So when it comes to the pipeline, so once you did the action handle, right? So what we need to do is like we need to ensure that this all the actions performed by various agencies has been captured, and you could use it for probably later evaluation, or you can use it for later judgment of the LLM capabilities, right? So you need to have a built-in learning layer as part of any of this kind of an autonomous pipeline. Okay, so what it can do is like it can document all the decisions and outcomes which is made by multiple AI agencies throughout the path that can be stored in DynamoDB, S3, and then feeding back we can provide this data back to the model, and so that it can train much effectively in the future. Hope all good so far. Okay, I think the previous one was more of a kind of an design architecture, and this is more of an implementation architecture. Okay. So when you are starting to implement these things, I think whatever I have explained, you may need to apply little differently from an implementation standpoint. So first is like the detection layer, which is I hope everybody is clear so far how the detection layer will work. So you get the events that will be in either probably in the CloudWatch and probably in the Datadog or some other log mechanisms, or it can be some place where you dump all of your logs and you are asking an agent to crawl and probably check whether the logs are there. So the detection layer will act like that. So once you get this anomaly detection monitors, you have to monitor this metrics continuously. Okay. Now there is an agent layer. So this is the place the multi orchestration of the agents comes into picture. So you are having a supervisor agent which will be directly connected to my detection layer. As soon as the detection layer kicks off, probably the supervisor agents stating that I got this alert, right? So it can invoke any other agents, whether it has to invoke probably the monitor, diagnose, remediate agents in that fashion. And then there is a knowledge layer. So once this, okay, the key challenges when we saw with respect to implementation of these things is like we don't have a lot of data, or like we don't have any kind of a KB or kind of a RAG which is associated with our past run books, or like what actions a team did when we had a pipeline failure. Okay, so all those things are not documented in many of the cases. That has been a key problem for us when we are trying to implement these things. Okay, so this knowledge layer will what it will do is like it will create the historical run books with respect with the knowledge bases and all, and then we can cross-reference past incidences for solutions. Okay. Now there is an action layer which will be executing the remediation steps, auto scaling, restarts, and the data quality checks. Okay. And then finally, we are having the learning layer, which will capture the feedback for the continuous improvement and the update knowledge base with the new patterns. Any questions? Okay, cool. Sure. Yeah. So in the maybe let me quickly go back to that previous slide. Okay. Yeah. Think this one. Okay. So in this is the kind of a native orchestration which AWS is providing. So what you have to do is like you have to create an agent. Okay. And you have to enable it for the multi-agent collaboration feature. So there is a toggle button. If you look at the AWS screen, right, there is a toggle button. You may need to enable it so that you can that agent can act like a multi-agent collaborator. Okay. So then what you have to do is like you have to create similar agents and which may be like kind of a sub agents, right? So then you have to add this sub agents to the inference agents to the main agent. So you create a supervisor agent. Supervisory agent is nothing but a kind of an agent which will be having the multi-agent collaborator facility is enabled on. Then you can create similar agents and then you can attach that agents back to the supervisor agent for the inference. So when the supervisor agent inferences the problem and understand that to which it needs to be routed against, whether it should be a diagnostic agent or a remediation agent, based on that information, it will invoke either diagnostic agent or the remediation agent. Yeah, you can do this through the multi-agent collaboration facility which is available in the AWS. If you want to do it outside of that, you may need to do kind of a state management. Probably let's assume that how it is happening in your workflow, right? You may be having multiple jobs in your Airflow DAG and all, right? So you may first task will complete, then you probably will decide what next to be done, right? So these things you may need to code it in a different way. So you might be having an AWS step functions where you have to. It should act like a kind of a state machine. So it should determine what next action it needs to be performed after this. Okay. Any other questions? Okay. Okay. So these are all the kind of an implementation steps when we are following the self-healing pipelines. So we need to create a knowledge base to store historical run books and best practices. And then you have to use vector embeddings for semantic search. And define of action groups. Okay, this is kind of important. So we need to know what are the actions which we need to do. So we talked about kind of a remediation agent and maybe like the diagnostic agent, right? So we need to clearly separate the boundaries for each of these agents so that they should not be colliding and maybe like you should be having the access boundaries are well defined. Okay, so you can use action groups for that purpose in which you can mention the pipeline operations like restart, scale, check quality, and all part of those action groups, and probably the what action it needs to do, whether it needs to connect it to your GitHub MCP server or whether it needs to connect it to something else, and all right, connect it to Lambda functions or executions, and all right. And then you may need to build the specialized agents, so monitoring agents, diagnostic agents, remediation agents. So in this way, you can separate the task of execution and the area of execution that will help you to understand where, let's say, monitoring agent is not performing up to the mark which we are expected, right? There are certain cases the model hallucinated. So you'll be able to easily identify through this specialized agents, monitoring agent and diagnostic agents and remediation agent, okay? Now the configure supervisor, so you can orchestrate multi-agent collaboration. Through that feature, you will be able to orchestrate multiple agents, okay, and through which you can manage the context and session state too. Okay. Moving on, I think I'll leave this. So probably when we go through this, when you create this autonomous agents for your data pipelines, right? So don't try to build everything with maybe like one or two agents. And also what you can do is like probably you can start small. So let's say you are having maybe like 100 plus pipelines in your organization, right? Maybe like start this experiment with maybe like the you can one single pipeline and try to see how you can expand gradually, okay? And always keep human in the loop, maybe like at least in the first phase, so that he can review the decisions. Okay, so when we try to implement this for the first time, we have a phase 1 and phase 2 approach. In the phase 1 approach, so we do the log analysis. So the LLM do the log analysis, and then it will provide that log output. And our production support personnel will also do the log analysis. So what we can do is like we will compare whether the results are matching or not. So in that way, we can validate that. And then the comprehensive logging. Okay, so this is kind of important if you want to do troubleshooting and if you want to see where the issues are happening. So you need to have a comprehensive logging too. And yeah, the guardrails are there to ensure the safety constraints to prevent any unintended actions. So you are having a 1 TB table, and what if the agent has accidentally deleted that table, right? So you don't want to do that, right? So you have to implement the guardrail feature also. So, and then the cost control, this is again another key part where you need to be aware of that. So you need to set strict budget alerts for the Bedrock API usage, and then the testing also. Okay. Yep. So these are all when we talk about the self-healing pipelines, right? I think these are all the things which I have covered in the previous slides too. So anomaly detection, continuous threading, root cause analysis, and automated remediations and validations should be part of that. Okay. And when it comes to the cost optimizations, so what we noticed is like there is around 65% of the engineering time is saved on this manual monitoring and incident responses. Okay, so when we looked at the data, so 60% of our engineers are spending time on monitoring the pipelines, which is not ideal. It's kind of a low engineering work which we don't want to do. So this kind of automation will help us to save that time, and you can effectively utilize it for maybe like a higher engineering activities and all. Okay, and then probably the mean time to resolution, that is called MTTR. So there will be an MTTR improvement, and infrastructure costs can be reduced through maybe like the optimal amount of services needed for your autonomous pipelines. Yeah, so these are all some of the key things, how you need to do what are the aspects you need to consider when you select the Bedrock models, caching strategies, and the batch processing and all. Okay, so apart from the learnings or kind of a cost, so we are having a lot of learnings as well. So one is the over automation risk. Okay, so when we try to put everything into a logic and try to feed that into an LLM or put into a AI, right? So it may not work well. So it will create a lot of hallucinations, model related challenges and also don't do that. So probably you can implement it. You can plan not to try automate everything. Probably try to automate whatever is needed. Okay, and then probably you can move on to the graduated autonomy. Probably move how the model is performing. Based on that, you can move forward, right? And then the model hallucinations. The foundation models is occasionally generate a lot of plausible but incorrect remediation actions and also yeah. So probably implement the strict validation layers will be helpful to ensure that the model is not hallucinating much. Okay, and then the context window limitations is when we are dealing with a lot of PySpark and maybe like the Python related work process and all, right, you are having large pipeline logs, so which may exceed the model context window. So what you have to do is like probably use semantic chunking to extract relevant log segments, and kind of you can implement a two-stage analysis process also. One is to summarize the log and then probably apply the log to then reason about the summary. Okay, and then the cost overruns. So set explicit iteration limits in the agent configuration so that it doesn't run endlessly. So implement the AWS budget alerts wisely. Use CloudWatch to monitor the token consumption and establish baseline costs before production rollout. Okay, so our POC was mostly done based on whatever is available in the AWS Agentic ecosystem as of now. Okay, there are a couple of new additions which has happened as part of the reInvent to 2025, and which is really helping us to make the life of, or like to make the automated data pipelines or the self-healing data pipelines much easier. So one of them is like the frontier agents. So this can work 4 days. So most of the AI agents currently we don't have that capability to run it for probably 8 hours or kind of a 24 hours, right? Which doesn't happen. So the frontier agents is going to help in that fashion. So it can work autonomously for days, not minutes. So this is kind of a paradigm shift where you can move maybe like a large production scale work process which needs continuous monitoring throughout the days and all you can do with the help of the frontier agents. And then the Nova 2 and the Nova 4, so they became more capable. So earlier, the reasoning capability has been improved much in the latest reinvent. Okay. And then we are having a lot of specialized AWS agents to the DevOps agent, security agent has been introduced, to the Kiro autonomous agent has been introduced. All these are all kind of a cool stuff where you can go and use it along with your data pipelines. Okay. And then another key feature as part of this one is in the Bedrock, I think they have introduced a policy also. I think policy was not part of the Bedrock Agentic core. Now they have introduced the policy also, so you can set policy at one place and then it will take care of the everything. Yep. To summarize our journey, I think it was kind of an exhilarating journey for us to start doing something with respect to the self-healing data pipelines. Okay, and so if you are planning to start this in your organization, okay, so probably you can take the playbook from our side and then probably implement in that way. So you can start with probably a small data pipelines and try to automate it using this, and then you can build incrementally, add more data pipelines, and based on how the performance and other aspects are there, and based on that you can build incrementally. And the key thing is like measure everything. You should measure how the agent is performing, and then probably the cost savings, time to resolutions, and engineering satisfactions and all, right? So these are all will help you to decide whether what you are doing, like your current pipeline, how the autonomous data pipelines will give the performance. Okay. And then upskill your team also. So there are long chain prompt engineering, maybe like the prompt chaining and right, and agentic AI patterns. Okay, so there are a lot of AWS workshops and certification process which you can choose to improve your knowledge. Okay. Yeah, that's it from my side. Any questions? Sure. Yep. Yeah. Yes. Yeah. Yes, the question is very valid. Okay, so what we are currently doing is like we have our CloudWatch logs are there. So the job will fail, or like it will be having some kind of an anomaly has been detected. We will be sending it to CloudWatch, and then CloudWatch, whenever there is an anomaly has been detected, it will be invoking kind of an agent, and then it will do the kind of a log summarization. Okay, and then it will be doing the next kind of agentic activity, right? So let's say it is kind of a remediation activity it needs to do. So what we did is like we strictly, if you are trying to do all these things together with probably one single agent, I think you will be having a lot of issues. Okay, and you may need to ensure that there should be knowledge base has to be established, right? So you might have taken probably, let's say you are running a data pipeline, right? So in the past, your production support person might have taken action on whenever you didn't get the file, right? So you know what action you have to take. Okay, so if you create a KB and where you document all the actions which your team did in the past, and probably you can augment with a RAG, which will help you to probably, let's say there are new changes which has been documented, either in the GitHub code, or it can be part of your any of the conference or SharePoints, right? You can pass all this information and to your agent, and then it will do the execution. So the problem which we found is like many times we don't have relevant documents to feed the agentic AI to take action on. So we may not be having a good KB to take action on it, and we may not be having a RAG also to supplement it. So when you don't have those kind of things, right? So your AI may not be able to scale up much, because it doesn't have enough contextual awareness of what is happening and what action we took when it happened in the past, right? So if you provide it with the RAG and the KB, and maybe like rightfully identifying what are the proper action groups which you have to implement when you need to invoke the remediation agent, or when you need to connect with the MCP server for the code analysis and all, right? So then I think you can make much inroads to it. So what we are seeing is that the trend is on this side. So probably we could see that many of the organizations are trying to offload their pipelines from the reactive mode, what we are seeing now, to more onto the automation or the automated path. Okay, so that's how the trend is going on. Yeah, but it seems like the cost and the probably the engineering bandwidth, right? So you may be having probably a 10-member team, and out of that 40-50% of the team effort is going to a manual activity, right? So if you could take that much money which you are putting into low effort or kind of low intelligence activities into this one, and use that what to say engineering for another activities, right? That will give lot of business objectives you could achieve. You could focus more on the business outcomes rather than dealing with this pipeline stuff. Okay. Yeah. Any other questions?